Assalamu alaikum. So my name is Abuzar Bharuchi and I am going to teach you Trial Division Primality Test Part 2. In previous part, I want you to remind you of what I have taught you. So I have reminded you of the definition of factors, the definition of prime numbers, and then I have taught you about how to check a number is prime or not. And I stopped the recording when I was going to teach you the another approach of checking a number is prime or not. So in this video, I will show you that another approach, and that another approach comes from two very sharp observation. And first, we will focus on observation number 1. So observation number 1. For a number n, there cannot be a number greater than n by 2 to be a factor of n other than n itself. So observation number 1, for a number n, there cannot be a number greater than n by 2 to be a factor of n other than n itself. So we will not check for primality test from 2 to n minus 1. We'll check from 2 to n by 2, making our work easier. Now I will give you some example and then I will prove you. So example, let us say 15. What are the factors of 15? So 1 divides the 15 completely, and then 3, then 5, then 15. Yes, no other factors are there. So you can see that 15 divided by 2, which is 7.5, and we are talking about a natural number, so we can take 7 also. So we can see that most largest factor is 5 other than 15. It is not exceeding 7, which I have showed you here, that for a number 15 there cannot be a number greater than 15 by 2. We can take 7 to be a factor of n other than 15 itself. So we'll not check from 2 to n minus 1, we will check from 2 to n by 2. So we'll only check from 2, 3, 4, 5, 6, 7. We will only check from 2 up till 7 for finding 15 is prime or not. So here 3 comes out to be a factor, so automatically we'll stop the process, and 15 is not a prime number. Another example is let's say 36. So what are the factors of 36? So 1 as always, 2, 3, 4, 5, 6, 7, 9, 12, 18 and 36. So you can see the maximum, most larger factor other than 36 is 18. And what is 18? It is 36 divided by 2 equals to 18. So you can see for a number 36, there cannot be a number greater than 18, 36 by 2 to be a factor of 36 other than 36 itself. We'll take another example so that you will be convinced. 30 factors: 1, 2, 3, 5, 6, 10, 15, then 30. Maximum is 15. Another maximum is 30, but we are not counting this one. As I have said you in observation number 1, that for a number 30 there cannot be a number greater than 30 by 2, that is 15, to be a factor of 30 other than 30 itself. Now if you are not interested in the proof, skip this. And if you are interested in proof, let me show you. So proof, let's say that alpha which belongs to n by 2 up till n, both are excluding. We are not counting n by 2 and we are also not counting n. We are counting the numbers between them. Let's say that alpha belongs to n by 2 up till n is a factor of n. So that means that alpha should divide n completely. So that means when we divide n with alpha, we should get remainder to be 0 and quotient to be some integer. But it is not the case. Let me show you that when we divide n by alpha, first let me tell you what alpha is. Alpha is any number between n by 2 and n. Let me, for more clarity, write 1 here. So the basic knowledge we studied in lower classes, that when we decrease the denominator, that is when we go from 2 to 1, we are decreasing the denominator, the overall value increases. So which is the simply case that n by 2 is less than n by 1. For example, 15, 32 by 2 is less than 30. You might be thinking why I am telling you this much basic. I will show you. So alpha belongs to n by 2 up till n by 1. So that means we will write alpha is equals to n divided by 2 to 1. Both excluding, as we are not including 2 n by 2 and we are also not including n by 1. So 2 to 1 excluding, the remaining numbers between them, that will be decimal numbers. All right, so n divided by, what is alpha? Alpha is n to 1. So n will get cancelled and will get 2 to 1, and this is quotient. So you can see that quotient is not coming to be an integer, it is some decimal number. So that means alpha do not divide n completely, because when we some number divide the given number completely, it should give remainder to be 0. It is giving remainder to be 0, but also should give quotient to be some integer, which is not the case here, because 2 to 1 we are excluding 2 and we are also excluding 1. Rest all the number are decimal number. So we have proved that alpha, where is alpha, is not the factor of n. So our assumption is wrong. So I have showed you also that alpha will for a number n, there cannot be a number greater than n by 2 to be a factor of n other than n itself. I have showed you here. Let's say that n is an even number. So that means n by 2 is equals to some integer, because when we divide any even number by 2, 2 divides that even number completely. So 2 is a factor of n. So we'll get some quotient to be some integer, because 2 is a factor of that even number. So here in this case we will get 4. This is some integer. So we'll get some integer. That means n by 2 is integer. So when we divide n with n by 2, we will get 2. Here what the divisor is also a factor, is also an integer, and the quotient is also coming out to be an integer. So in the definition of factors, I want to remind you of the definition of factor. As I have said, that for a natural number, a factor is a natural number which divides the given natural number completely. So here n is a natural number, but we should not forget that the divisor should be a natural number. So in this case, both the condition are coming out to be true, and quotient is also coming out to be some integer. So that means that n by 2 is a factor of n whenever n is an even number. So when n is an even number, we'll check from 2 to n by 2, both including, because n by 2 is also a factor of n. Here I have said you excluding. There are two cases: in even number and odd number, the result is different. That's why I have showed you first result of excluding, then in when even number is there, we check from 2 to n by 2, both including, because n by 2 is also a factor of n. Now case number 2, let's say that n is an odd number. So that means n by 2 does not belongs to integer, because you can take some example. 15 divided by 2 is 7.5. So 2 is not a factor of that odd number, so it will so quotient will be some decimal, it will not be an integer, so 2 will not be a factor of n. So when n is an odd number, n by 2 is not an integer. So when we divide n with n by 2, when n is odd and this is not integer, though we get 2 to be quotient, but this will not be considered to be a factor. This n by 2 will not be considered as a factor of n, because in the definition of factor is a natural number which divides the given natural number completely. So here n is natural number, but n by 2 is not a natural number. It is not an integer, it is some decimal quantity. So even though it will divide this completely, it will not be considered in the definition of factors. So when n is an odd number, we'll check from 2 to n by 2, 2 including but n by 2 excluding. So conclusion is this, that whenever we want to check for a number is prime or not, we will now not go from 2 up till n minus 1, as in the I have showed you in part 1. We will only go from 2 to n by 2, and in either case, even if n is even or n is odd, we'll max to max go from 2 to n by 2. So my friends, this is observation number 1 of another kind of approach, and in the next video I will teach you about observation number 2. That is very sharp observation and it requires very much of thinking. So wait for the next video and I will see you soon. Thank you.